Hello, my name is Shane Cook, and this is the first video in a three-part video series going over three common data structures used in programming. I'm making these videos for my final project in the Programming with Data Structures course taught at BYU, Idaho. The first data structure we're going to be going over today is the stack data structure. Before I continue, please note there are several prerequisites before diving deep into these topics. The first prerequisite is to make sure you have a basic understanding of Python or a programming language. The examples I'm going to be using in these videos are all written in the Python programming language, but if you have experience with programming in general, these concepts should not be difficult to understand. The second prerequisite is a knowledge of Big O notation. If you aren't familiar with Big O notation, there's a couple of really good 2, 3, 4-minute videos that talk about it, and I invite you to watch those if you're unfamiliar with the topic. What is a stack? A stack is a linear data structure that holds its elements in a last-in, first-out manner. What is a linear data structure? There are two main types of data structures in programming. They are linear ones and nonlinear ones. Linear data structures have an arrangement of the data which follows a linear trend. So for example, you see my mouse right here, we've got the first item in the data structure, which goes on to the next one, and the next one, and the next one, and the next one, and the next one. And then of course a nonlinear is typically a hierarchical data set where you have a main node, which has several child nodes, and they themselves have child nodes as well. To keep it simple, linear data structures are in a straight line, while nonlinear ones are not necessarily. What is last in, first out? Well, last in, first out means the last piece of data or element added to the stack will be the first element removed. So imagine a container of tennis balls. Usually they come in packs of 3. For the sake of the example, imagine the plastic packaging that the balls are in is indestructible. The only way to reach the tennis balls on the bottom is by removing each ball one by one from the top. That's just how a stack works. As you insert data or elements, you need to remove the last one first to get to the specific element you're looking for. So for example, if we're wanting just to get to the bottom, we need to imagine that this container is indestructible. We can't just rip open the bottom. We have to pull each ball from the top one by one so we can get to this one. How can a stack be represented in Python code? Python supports the stack data structure in the list object. A Python list is defined by naming the variable and having it equal to an opening and closing bracket, just like what's on line 4. If you want to define it with preset variables, you can add them when you're defining the list, just like this. Let me change the name so it might make a bit more sense. Let's just do my other list. So my list, of course, is empty, right, when we define it. And my other list already comes with these preset variables, 1, 2, and 3. There are several operators that can work with a stack: push, pop, size, and empty. The first one, which is push, is represented by the append method in Python. It takes a value as its argument and adds the value to the top of the stack. Here's an example. Imagine that 1 is the bottom. The first element in a Python list is the bottom of a stack, and of course the last is the top. So when we append or push 6 to the top of the stack, the list would then contain 1, 2, 3, and 6. The push operator yields big O1 efficiency because the method simply adds the argumented value to the end of the list. The pop method takes no arguments and removes the first item on the top of the stack. Here's an example. Remember, we had 6 as the top of the stack, and when we use mylist.pop, my list will now contain 1, 2, 3, and 3 is the current item that's on the top of the stack. The pop method yields big O1 efficiency because the method simply removes the element at the top of the stack, which in this case is the end of the list. The size operator is represented as the length method, which takes the stack as its argument. Here's an example. Length equals len, and then takes my list as the argument. This right here should yield the number 3 and store it in the length variable that we just defined. The size operator, or length method, yields big O1 efficiency because it simply returns the size of the element, which is constantly kept track of by the computer. The empty operator is represented as the length method in tandem with a Boolean test. If the Boolean test passes, true is yielded and false is vice versa. Here's an example. We have this variable that we've named empty, and we have it equal to the result of this Boolean test. If the length is equal to 0, it'll yield true, which means it's empty. If not, then it'll yield false. The empty operator, or Boolean tested length method, yields big O1 efficiency because it simply returns a Boolean value according to whether the size of the list is 0 or not, which, as I mentioned earlier, is kept in memory by the computer. The most common error when working with stacks is trying to pop an element off an empty stack. An easy solution to this problem is setting up checkpoints in your code to check for errors. Here's an example. We have a stack taken in the argument in this function named example. And while the length of the stack doesn't equal 0, it'll print the stack and pop it off. This is a bad example of working with a stack. Instead of it being 0, we have it equal to -1. While length of the stack doesn't equal -1, print the stack and pop it off. These two do the same exact thing, but the error lies in the check right here. Each time the length of the stack will shrink by 1 when an item is popped off, but the length of the stack will never equal -1. So once everything is out of the stack and the loop goes around to pop off on the empty stack, it'll return an index error. Let's run it. As we can see, the beginning stack is 1, 2, 3. It then pops off the last item, the item on top of the stack, and we have 1, 2. Pops off 2, we have 1. Pops off 1, and we have nothing. When the program attempts to pop off on an empty stack, we get this error right here. Index error popped from empty list, or in our case, a stack. What kinds of problems can be solved using stacks? Stacks can solve all sorts of problems. An easy problem we can solve with a stack is figuring out if a word or phrase is a palindrome. A palindrome is a word or phrase that is the same spelled backwards. An example of a palindrome is the name Hannah. Let me write it up here just so you all can see. Hannah is spelled H-A-N-N-A-H. If we were to spell Hannah backwards, disregarding the capital, we would have H-A-N-N-A-H. And that's an example of a palindrome. To begin, the first thing that we need to do is set up our code, which I've done so. I have this passed as a placer variable so we don't have an error, but we're going to be removing it in just a moment. The most important step is converting the string to a lowercase and removing all spaces. We can do this by going new string is equal to string.strip. And right here, we can have inside the argument for the .strip method a string of a space. Now notice I have an error going right here, and that's just because string has not been defined. So I'm going to have in the argument string. The next thing that we need to do is remove all the spaces. So we're going to go down here, we're going to go new string, is equal to string, or I'm sorry, new string dot lower. And what this is going to be doing is converting all of the uppercase letters to a lowercase. The next thing we need to do is convert the string into a list or a stack. We can do this by first creating a new stack. We'll name it front. The next thing we need to do is we need to append each character of the string onto the stack. So for char in string, go front, append, char. So as it parses through the string, it'll add a letter to this front stack. Now we need to reverse the stack. We can do this by pushing and popping from the front stack to a new stack, which we're going to name back. There are a lot of ways to go about doing this, but staying within the constraints of a stack, this is the most optimal way to go about it, while holding true to the principles that have been taught so far. We're going to go while length front doesn't equal 0. We can go char equals front.pop. The first thing that we're doing here is storing the value that's on the top of the front stack into this variable named char. After we've done that, we can simply go back.append char. This is really neat because we're simply pulling off the top and putting it on the bottom. And this is going to loop until front is equal to 0. Once the loop has looped through the entire front stack and added all of the front stack to the back stack by popping and appending, we need to make sure that the comparison works, that the string is a palindrome. We can do this by saying if string is equal to an empty string dot join back. This comparison right here is saying that if this string is equal to the back string, which this .join method essentially takes a string, which we have this empty string right here, and joins all of the contents of this list into that string without any spaces or anything, unless there are spaces within it, which in our case there's not. So if string is equivalent to the back string, or is it backwards, we're going to go print pass. Let me pull that right here. So we're going to go print pass, and then we're just go else print fail. Now this is the entire code blown up, just so you can see the entire process of it. And it's a very simple way to go about using a stack to check if a string is a palindrome. Now, even though this string is simple, it doesn't account for any punctuation, which when you're working with more complex palindromes, it's super necessary to account for that. So the only strings that it can take are strings that don't contain any punctuation, which you can add a check for around here on line 5. All right, I do want to make one quick edit to this string. So we're actually going to say if new string is equal to join back right here. And then we're going to go for char in new string. The reason why we're doing this is because we're not comparing it to the original passed argument string, because remember we created a new string, which is the string stripped and lowercased. And when we compare the new string in these instances, it's not going to include those spaces or uppercase letters that we originally had. Now with that easy example out of the way, it's time to try something a little bit tougher. You're given a string consisting of lowercase letters. A duplicate removal consists of choosing 2 adjacent and equal letters and removing them. We repeatedly make duplicate removals on the string until we no longer can. Return the final string after all such duplicate removals have been made. It can be proven that the answer is unique. So for example, we have this string right here, A, Z, X, X, Z, Y. And it should equal AY. And going through the thought process, let me walk you through it. So we first have the character A. There are no duplicates on the empty stack, so we'll just go down here and we'll just say A. Next we have the letter Z. And Z is not the same as A, so we should be able to just add it to the stack. Now we have the letter X. Okay, well, there's no X's next to it, so we'll just go X. Oh, now we have the letter X, and instead of adding it, we're actually going to remove X. Now we're on to the letter Z. Oh, there's a letter Z right here. So now instead of adding it, because there's a duplicate, we take it away. And last but not least, there's a Y. And that's how you should be able to come up with the answer right here. Now I'm going to give you 20 minutes, set a timer for it before I explain the solution. And if you can't solve it, come back here and I will explain. If you finish early, walking through my explanation might help deepen your understanding of stacks and could even show you another possible solution. So whether you figured it out or you didn't, come back when you're done, whether it be 20 minutes or sooner, and we'll take a stab at it. All right, are you guys ready? Because I am. The first thing that we have to do is, of course, create a function. So I'm going to call it remove duplicates. And we'll take a string as the argument, and then of course I'll throw in a pass down there. The first thing we need to do is create a stack, and I'm just going to go up here, I'm going to go stack equals empty list. Now we need to parse through the string. We're going to go for I in string, or we can go for char in string, whatever works for you. So for char in string, now we need to check two things. We need to check if the last item on the stack, or the item on top of the stack, if it's equal to the current item. So we're going to go if char is equal to stack -1, index -1. And what this is telling the program, index -1, when we're indexing, all that does is it says look to the last item on the stack, because of course if we did index 0, it's going to be the first, and there's no such thing as a -1 index. That's just how Python lists work. So if char is equal to the last item on the stack, we're going to go to stack.pop. Now there's another thing that we need to do here, and I'm going to explain it in a second. The next thing we got to do is an else statement. So of course, if this doesn't pass, we'll go down here to else, and we'll just go stack.append I. I'm sorry, not I, char. So this is really cool, right? We've got, we're just going to be appending it each time, and we're popping it if it's on there. One issue we run into really early on is, so this looks good, right? We're making good progress. The only issue is when we're making this first comparison, it's going to try to check the top of the stack. But before we even begin doing this loop, the stack is empty. So we also need to check if the stack has any items in it. So we're going to go and stack. And all this is going to do for us is it'll yield a true if the stack has something on it. If the stack is empty, it will yield false. So now that we've got this out of the way, we last need to make a comparison, and I can remove this pass by now. And we're going to go return empty string.join, remember using the .join, and stack. One quick correction, you do need to make sure you have your stack check first, and then this, because it's still going to yield an index out of range. But when we go down here, and run the code, we have a y, which is what we had said that would happen with this string. I hope you guys enjoyed the video, and I hope I gave a pretty easy rendition of what a stack is, how it's applicable in programming, and what you can do with it. If you liked the video, type in a like. If you found something that I could work on or have an extra tidbit of information, just leave a comment. And I hope you all have a good one. Bye!